Hello there. My name is Chris Fernandez. I'm a solutions engineer with Keysight Technologies. This is video number three out of three, talking about MACSec fundamentals. Videos one and two, we discussed the concepts of MACSec, testing a software-based MACSec on a Keysight technology Novus card. So what I'm going to go over on this video here is the usage of the L4 and L7 is stateful application traffic. That's going to give us a little bit more information on the encryption and encryption capabilities of Ixia. Since the traffic is not as high speed anymore, not like L2 or 3, where it's focused on performance, L4 and L7 will give us more since it's a little bit it's slowed down version of what we can do. We can actually have more capabilities. For example, the capability of encrypt and decrypt traffic uh, on the fly, as well as have MACSec statistics, which we can't do on layer 2 or layer 3, where we are performance based. So for starts, we always start with the same way, which is bringing in ports from our current chassis into our session. So our session, I'm using IX Network 10.0, and I'm on my current PC where this is installed. Read the chassis, and it's going to connect, and then I'm going to bring in my two ports that I'm going to use for my testing. As the ports are coming up, they're going to come up, and they're going to come up as a default value. Right now, they have those are two 10 gig ports. They're connected back to back using fiber. So I can go actually start building my scenario here. So under new topology, I'm going to pick my port number 1, and I'm going to add my statically MACSec and MKA in this case. Hit finish. I'm going to use 3 devices only. I'm not going to do more. And for now, I'm going to leave the MKA as default. Before I go any further, one thing that we got to set, because this is the L4, L7 application traffic, we can change this encrypted traffic type here to L4, L7. When you do that, that's going to give us the ability to actually add an IPv4 layer into this stack here. So I'm going to go here back to static MACSec, and under add protocol, I'm going to add IPv4. So now under IPv4, I can actually have 3 IP addresses. So I have 3 hosts in here. So I'm going to set 172.16.1.1 and 3 hosts. So I'm going to use /24, prefix /24. And the gateway, I'm going to set to, which is going to be my other side. So 172.16.1.10, 1.1, 1.11. So I'm going to have 1, 2, and 3 on one side, and 11, 12, and 13 on the other side. And as soon as I start protocols in this case here, he's going to try to resolve the gateway. So he's going to send the ARP to the other side, which will be encrypted traffic going to the other side. So now we're going to have a communication on layer 4 and 7 encrypted both ways. So for the other side, I'm going to do the same thing. I'm going to now bring in port number 2. I'm going to static MAC and MKA. I'm going to hit finish. And I will have 3 hosts on this side too. Same thing here. I'm going to set this encrypted traffic to L4, L7. That's going to open up the ability to add the IPv4 layer on my stack. And I'm going to set this to 172.16.1.11. And this will give me the increment. So I will have 11, 12, 13 on this side here. I'll leave the prefix as is, and I'm looking at the other side now. So 172.16.1.1 and 3 hosts on the other side. So they are hosts on the same network, so that's why they can ARP each other out and it should work. So for now, now let's look at the MKA. The MKA here is where you define the function, the cipher that we're going to use. We're not going to do anything fancy here, so we're just going to leave the 128. We're going to leave the server priority all the same here for 70. And since I want to, let's say that since this 3 hosts here are going to be actually part of the same session, so let's try to specify a server so we can know how the key server priority works. So we can leave it as is right now, and the lower MAC address will win. So this side of the topology one here is going to be the one that probably the number one here is going to be the server, and then we can mess around it and change it. So I'm going to leave it here. The PSA key chain, so the pre-shared chain here has keys. They're all the same on both sides. So they should come up as one session. So everybody's going to be part of that same session. But on this side here in topology 2, they're using MAC address of starting at 27. So that means that they're going to have, they're not going to be a key server. So for now, I'm just going to start protocols here. One thing that you can actually do on layer 4, layer 7, stateful traffic that you cannot do on layer 2 or layer 3 is it's the rekeying based on the packet number. So that is done over here on the MKA. Which right now the key mode is it's time based, but the behaviors don't rekey. So if you want to do based on packet mode, you can create this. You can change this to packet based, and then you have the rekeying here. So this number here is probably around 3 million packets or something. So I'm going to leave it as is. They're not rekeying now. We can just see how things work as things come up. So as things are coming up, everything come up, so everything is green. That means that the IPv4 layer that is encrypted this time, everything worked. So the ARP worked across. And we can take a look over here on the MKA and go look at runtime information. And you can see, as a matter of fact, that the server is the number one here, which is what we expected. So for example, let's say that we want the last here or the middle device here on the other side on the topology sheet to be the key server. So all we have to do is go back to our scenario here under MKA here, and then we can actually change the key server priority for this particular number 2 here. So let's say that we can set this to 69. And that was going to be highlighted like this. When it's highlighted like this, you can tell that there's this red marker here. It's just saying that it's not equals as the global configuration. So think as this blue line on top here as the global configuration, a configuration that will be used by every device under this configuration here. But when you have the red indicator here, it's just saying that this particular one here is not following the global, whatever the global is. And you see that this number here is in bold. That means that you made a modification, but you did not apply. So after you made a modification, this is just blue here. We can just apply the changes. And then as soon as we apply the changes, we can go back here to MKA and look at the information, the runtime information again. And now we can see that the key server now has a lower priority. So he won the key server election, and now he is the key server here. So information about the keys are done over here. And then if you right click on the MKA here, on any of those devices, you can get learned information. So this learned information here is what you're going to see over here that talks about the ICV key and the key encryption and the secured association and SALT if was being used. So So learn peer information. So as you can see, one device uh, has actually a session with the own side, right? So one device that's on topology 1 has sessions with its two other devices, 2 and 3 here, and all 3 members of the other side. So this is what you can, that's the information that you can get about, I'm talking here about what I'm getting from that first device. That we can do to make sure that the traffic is being encrypted and it's working as advertised, we can actually ping the other side. So for that, let's do a capture here. So I'm going to do a capture on port number 2. It's a control plane. It's a control plane traffic. So I'm going to use the control plane uh, traffic capture here. I'm going to start capturing here. And going back to the scenario here. So captures is started. So I can go into my IP here, and I'm going to send a ping to 172.16.11. I'm going to ping 5 times, interval of 5 seconds. So as you can see, he's sending the packet request here. I'm going to close this, and I could go back to my captures here, and I'm going to stop the captures. And there's a lot more captures here because the MKA protocol is enabled. So I'm going to open this up. As you can see here, there's a lot of MKA traffic. I'm going to be based on protocols here and try to look for my pings. And here are my pings. So you can see the ping request being sent out. And you can actually look at the decryption of the packet here, right? So it's a ping request coming from 16 to 11 and the reply. And it's all secure. So if you look at the packet here, you can actually take a look at the security tag. You can see the ICV is correct. So the integrity of the packet is correct. And they're pinging back and forth using encryption. So the last thing I want to show really quickly here is traffic. So for you to create application traffic that is encrypted, and we can get some MACSec statistics, I can look for, I'm going to send packet from one side to the other, and I'm going to say next. And over here, I'm just going to use some simple HTTP bandwidth test. Now I'm going to add that flow. It's going to simulate 100 users, or I can do throughput. So I can do 100 meg throughput as my objective. I say over here, you can actually see the MACSec purport and encrypted packets being sent out. So this is a get, so you're going to get a lot more receiving end than transmitting. The transmit is a simple get, and you're going to get a video. So this is the number of packets transmitted, and the statistics here can give you SIC discarded packets, for example, out of window, and bad tag, ICV discarded packets. Anyway, invalid ICV received, and so on. So those are statistics for our MACSec that are only available when you're doing layer 4 through 7 traffic, as well as the MKA statistics. So you can see here the MKA statistics based on the control traffic, right? On the protocol itself. Okay, so this is all I want to show on this video. Please let me know if you have any questions, and we can go from there. Thanks. Bye.